Hello and welcome to the channel. This time I have done some modifications to my robot. This is there was two boxes, the upper and the lower box. You can see actually both open now. This one has some of the electronics, as I already showed in previous videos. This one, originally I was supposed to use a Chinese controller, which is that one over there, the black box. But I tried to debug and kind of like see, reverse engineer how it's working and its innards, and especially the protocol, and that became a bit more tedious and not so. So I decided, like, okay, let's try something else. And I had an not older, but earlier in another project, I bought a Robotic FBL2360 controller, which has two channels, one for each wheel. Originally, it was seemed like a very good purchase when I bought it from US, but let's just say after configuration and trying with hub, wheel motors and so on, it seemed to have a lot of bugs and a lot of problems. I initially used the HBL version, an earlier model of it, and I returned it because it didn't work. They even knew that some of them might not work because there was some sort of design fault or component fault, whatever it was, but I changed it to this one. This one uses, instead of having external heat sinks, it's connected straight to the aluminum chassis of the robot, cools itself that way. And well, with the software firmware which I had when I bought this, I think it was 1.7 or 1.6 something, it was pretty horrible, a lot of problems. Now came the new update a while ago, and that's why I decided to give this one a new try. And I'm glad I did, because the new update corrected pretty much all the problems which I had before with this one. Now it works perfectly. There's the connections to the... these are the connectors used in the Chinese controller. I just decided not to remove them and just take the connectors out from the box itself. This Chinese controller. I just took the connectors actually out. They were with the crimp connectors inside the mother electronics, the circuit board of the Chinese controller. And I just transferred them straight into this one, like each one here, perfectly colored and all. Here's the cables for the electronic magnet brakes, for the motors, and I didn't connect them yet, but I will eventually connect them to the digital outputs of this controller. And there was also these colorful cables are the Hall connectors, and those I've already packed inside here, but I made a kind of adapter of my own. There's screw terminals underneath. They're easier to try out, because when you connect a model like this one and you're not sure about the colors of each phase, are they the same from the Chinese manufacturer and from this controller manufacturer, so you just need to try through several combination of phases, and then with each one of them try various combination of Hall sensors, and usually find few solutions that work, and out of those different solutions, that when it actually rotates without making any sounds or something, out of those usually one or two is more smoother than others, and you choose the best, which appears to or sounds the best one. And basically after connecting these motors to it, I had to add a lot of electronics, which is the controller is nice because it's designed for robotics in mind. So it has a lot of safety features. You can program with the scripting type language, and a huge amount of configuration options. So it was had a lot of choice. But for the safety, as a result, okay, this looks a bit messy here, but there's basically some resistors, diodes, fuses, and here's a relay, main relay, so that I can switch it off from the controller itself. If there becomes a fault inside with the MOSFETs, for example, it can switch the main power off of its because there's two power supplies in it, one for the controller inside, one for the switching side of the motor controller. So you can power out the main part of the controller for safety. and there was fuses and diodes, a lot of stuff added for safety purposes. Also, as a result, I added an emergency switch, in a box like this. I put it to the rear as I was figuring out it's most likely if this one runs away, I'm going to be running after it. So it's probably the easiest place to kick it or get the switch down. However, also the one reason which I put it here is that I'm planning to put ultrasonic sensors here on sides to detect when the robot is moving sideways or backwards, to help it avoid collisions in those directions. Though I'm having trouble choosing the ultrasonic sensors, because most of the ones for robotics for sale, they're not really water or weatherproof in any way, they're for inside use. And the ones which are weatherproof unfortunately have a range usually starting from 25 or 30 centimeters, and below that they only give an indication that something might be nearby. So I'm still trying to figure out which would be the most suitable ones to put here. I can take the cabling for this one, and another change which I did to the robot is that before I had an aluminum profile in the back here, which was only half of this thickness. And okay, it didn't bend, it was fine, but I was thinking maybe I got overly cautious that in case big impacts happen or something, despite the suspension in this caster wheel, that it will not bend, and I just added up and bought a thicker, bigger one. But the advantage is that there's a hole here, so I can pull all the cables for the sensors, everything here through this route, and also if I want to put them elsewhere, so I can use this as a cable conduit as well. One missing there is now, there used to be an Arduino controller here, and I'm planning to use that to control this. You can control this through CAN, analog, RC pulse connection, or standard RS232. This model is the fun, but they're supposed to have TTL in it for serial connection, but it's not implemented, at least not in this firmware version. And so I just got myself an RS232 converter just to connect it to the Arduino. And the Arduino is currently here. This is what it looks like next to my coffee cup. This is Arduino Mega. I put the IMU shield there, basically a 9-axis motion shield. Then I'm also going to put a Wi-Fi shield on top, in addition to the RS232 connection. And then I will use the Wi-Fi shield. I got one which actually has an external antenna connector, so I can pull the antenna in suitable spots on the upper box of the robot. And all the different parts of the robot, using basically ROS, can then independently connect to this system which controls the main motors. This Arduino, I was initially planning to just put the basic kit functionality here and some of the sensor functionality for IMU and what the ultrasound sensors into this one. But instead of externalizing to Raspberry Pi, I decided to try to put a small neural network here running on this Arduino, just a very small one, and let it take care of that, everything inside here, so that all the other parts of the robot need to only just kind of notify this what it wants to be done and so on. So it's more of an indirect control. Let's see how it will work in the end. And I got myself this new Intel Movidius USB stick, which I'm planning to somehow use in this part, at least give it a try, see how I can get it to work. But I think it should arrive hopefully next week. Thank you for watching.